Chocolate making process. Chocolate making process. Step 1. Cleaning. Step 2. Roasting. Step 3. Shell removal. Step 4. Nibs are ground. Step 5. Cocoa is separated from cocoa butter. Step 6. Other ingredients are added to the chocolate liquor. Step 7. Conching machines knead the chocolate paste. Step 8. Chocolate is tempered by heating, cooling and reheating. Chocolate. From cacao bin to chocolate, cacao bin storage area must be isolated from the rest of the building to protect the sensitive bins from strong odors that might be absorbed. Good air circulation and a cool temperature are important, and the humidity regularly checked. You must be able to identify the beans according to their particular type and origin in order to control the flavor by blending beans for roasting. Step 1. Cleaning. The process of making chocolate starts with the cocoa bins being passed through a machine that removes dried cocoa pulp, pieces of pod and other extraneous material. The bins are carefully weighed and blended according to specifications. During cleaning, a magnet first removes any bits of metal. A blower then extracts dust and dirt, wood and fragmented bins. Finally, using a combination of gravity and vibration process, everything that's heavier than the cocoa beans is removed from the machine. For example, small stones. The clean bins are then transferred to a funnel-shaped silo and, from there, fed via an intermediate silo into the reactor below, where they are sterilized. Pressurized, hot steam at a temperature of 150 to 170 degrees Celsius kills all germs in just 3 to 5 seconds. Step 2. Roasting. Cocoa beans are roasted in large rotary cylinders. Depending upon the variety of the beans and the desired end result, the roasting lasts from 30 minutes to 2 hours at temperatures of 250 degrees Fahrenheit and higher. As the beans turn over and over, their moisture content drops, their color changes to a rich brown, and the characteristic aroma of chocolate becomes evident. Although all steps are important, proper roasting is one of the keys to good flavor. Roasting reduces the water content of the beans from about 6.5% to about 2%. Step 3. Shell removal. The cocoa beans are cooled quickly and their thin shells, which have become brittle by roasting, are removed. A giant winnowing machine that passes the beans between serrated cones so they are cracked rather than crushed. In the process, a series of mechanical sieves separate the broken pieces into large and small grains while fans blow away the thin, light shell from the meat or nibs. Here's where the first secrets of the chocolate manufacturer comes in. The nibs are blended, combining as many as 8-10 varieties. It is control of these subtle mixtures that maintain constant quality and brings out the flavor of each particular variety of chocolate. Step 4. Nibs are ground. The nibs, which contain about 53% cocoa butter, pass through refining mills and are ground between large grinding stones or heavy steel discs, creating a cocoa paste. The paste is subjected to hydraulic pressure, and the cocoa butter flowing out is a pure and valuable fat with a marked aroma. After filtering and purifying, it looks very much like ordinary butter. Step 5. Cocoa is separated from cocoa butter. Up to this point, the manufacturing of cocoa and chocolate is identical. The byproduct of cocoa, cocoa butter, is the essential component of chocolate. About 25% of the weight of most chocolate bars to make cocoa powder chocolate liquor is pumped into hydraulic presses weighing up to 25 tons, and when the pressure is applied, 80% cocoa butter is removed. The fat drains away through metallic screens as a yellow liquid, and then is collected for use in chocolate manufacturing. Cocoa butter, unique among vegetable fats, is a solid at normal room temperature and melts at 89 to 93 degrees Fahrenheit. Just below body temperature. With proper storage conditions, cocoa butter can be kept for years without spoiling. The cake which is left may eventually be made into cocoa powder by being further crushed. milled and finely sifted. 3 or 5 vertically mounted steel rollers rotate in opposite directions. Under heavy pressure, they pulverize the tiny particles of cocoa and sugar down to a size of approximately 30 microns. 1 micron is a thousandth part of a millimeter. Most manufacturers add non-fat milk, flavors, sugar and other ingredients. The resulting product will contain between 10 and 22% cocoa butter. In the Dutch process, cocoa is treated with an alkali and develops a slightly milder flavor, and has a darker appearance. Step 6. Other ingredients are added to the chocolate liquor. Milk chocolate is made by adding milk, sugar, cocoa butter and other ingredients to the bitter chocolate liquor. At this point, chocolate is prepared in according to individual recipes. The blending of the various types of cocoa pastes and other ingredients determine the ultimate taste. The ingredients go into a mixer with rotating, kneading arms until the result is a homogeneous, paste-like mixture with a pleasant taste, but it still feels gritty to the palate. Step 7. Conching machines knead the chocolate paste. This process develops flavors and changes the texture during controlled temperatures. It's the last and most important refining process, which allows the separate flavors of the individual ingredients to combine. Conches, the paddles of the early machines resembled conch shells, are equipped with heavy rollers that plow back and forth through the chocolate paste, anywhere from a few hours to several days. Contemporary technologies can grind the chocolate particles extremely fine, which can reduce conching times. Swiss and Belgian chocolates are conched as much as 96 hours. Some chocolates are not conched at all, or for only 4 to 12 hours. Step 8. Chocolate is tempered by heating, cooling and reheating. This thickens the chocolate and imparts the right flow properties for filling the molds. This complex operation is performed in the tempering plant and is necessary to give the final chocolate product a delicate composition, a uniform structure and a well-rounded flavor. The storage life is also increased in this way. Liquid chocolate is temporarily stored, a necessary step. Conches are always filled with the largest amounts of chocolate for efficiency. The molding machines can only accept small amounts of chocolate paste at one time, in order to shape it into bars, chocolates and other products. Chocolate is frequently shipped in a liquid state to other food manufacturers, or it can be stored for short periods of time. For longer periods, it is solidified, usually in the form of 100-weight blocks. These blocks must be reheated before further processing so that they liquefy again. Main ingredient in chocolate. Ingredients: milk, dark and white chocolate all contain sugar, cocoa butter, full cream milk powder, cocoa liquor, lecithin, vanilla and cocoa. Milk equals H1O8 H2O Car 20P 15 mg 12 Fe 26 Mo 42 C6. Sugar equals C6H1O8. Salt equals Na11 Cl17. Cocoa equals C6H1N7O8. Calories, fat content and additives will vary depending on the type and brand of chocolate consumed. 1 calories counter lists milk chocolate, white and dark as containing 535, 539 and 540 calories respectively in each 353-ounce serving. All 3 types of chocolate contain sodium, riboflavin, vitamin E, sugars, calcium and potassium. They also contain protein. Dark chocolate wins in the fiber category, with 314 grams per ounce. Milk chocolate has 0.57 grams, and white chocolate contains no fiber. Dewan Digital Marketing, Painmark, the GMAT. Saifs blogs.